So this is messing with the ultrasonic sensor HC-SR04, which they sell in kits for the Raspberry Pi and Arduino. And I'm looking at the trigger, which triggers on the falling edge, and then it has a small pulse on the echo receive. And what I'm wondering is, can I find out which one is the transmit and the receive? I could just probe right on the board, but it's not as much fun as taking this ultrasonic. This is a piezo ultrasonic sensor I used 40 years ago in a company in Reno, Nevada that was doing snowpack measurement in the Sierras using ultrasonics, and they would put two of these in a little head with an 8031 microcontroller and do remote telemetry with meteor burst communications bouncing off meteor trails in the ionosphere to telemeter the data from the Sierra Mountains down to their collection center in Reno. So that was 40 years ago, and I was doing 8031 programming, assembly language. So I pulled it out of my box, and this one still responds. If I'm just going to tap on the face, and you can see that the third trace down here, it puts out, like if I physically tap on it, it puts out a few volts. So I know it's responding, but in order to get the signal, I'm going to go up and get it right on the face, but it's such a low amplitude. I have to go to the max, and the Siglent here, let's say 10 millivolt per division. 5 millivolt per division is the max you can get with a 10x probe. But then I know the signal is something around 40 kilohertz, so voila. Now, so I take no signal. There's the receive trigger, return echo. This is the piezo, and I touch it and it goes off scale. So now I put it on this face of this one, no signal, and put it on, so no signal on this face. And then, so this one must be the transmit. Aha, there is a signal. And let us see, if I just capture it and just say stop. Stop, and then I can zoom up. That's the nice thing about Siglent, is you can zoom after you capture. And I want to see the frequency here. So, oops. So that says 40 kilohertz. Yeah, delta is 24.6 microseconds. 1 over delta is 40.6 kilohertz. So that is right. And then the pulse width looks... So this is a case where it's not getting an echo, so it keeps transmitting. So it looks like it does change the pulse width until it gets an echo. So let's see. So here it thinks it's getting an echo, and you can see the pulse width. What I guess I need to go AC couple on this. Because it's just bouncing. But I don't know if that's going to help. So, I turned it off. No, it doesn't help. Anyway, so it goes out of range. So I'm trying to see if it changes the time it's transmitting, but kind of hard to see. I could do just single sweeps. Let's see. Get how to do that on here. You go into run and it goes single. Oh, is that a normal trigger? Just a single button down here. Boink, and there's a signal. So here it's long return time. There's another one. Oops, that's not too clear. Short return time. So it's got an echo and it's got a short burst of, that's only like 1 millisecond. The burst. There's another one, a long return time, and it's still a millisecond burst. That's pretty consistent there. Millisecond burst, short return time. Anyway, so we know it's 40 kilohertz, so we know it transmits out of this one. I guess that's about it for that.